Right? Okay. Let's see if people connect, hopefully.
Is the test going to be on Wednesday night? I would make it online.
What's that?
I would make it online personally because there's kids that are.
Yeah, we're probably gonna have to do an online one. Everybody's gonna be in.
I just won't be here on Wednesday, so I don't know.
Okay. Remember, it's gonna be a two-parter. So like the solve, I'll sort of like we're gonna have some stuff on just solving equations and some stuff on lines. So you'll get one part probably on Wednesday, unless I push it back to Friday. But we'll plan on Wednesday for now. And then.
I'll help them out.
Yeah, I'm thinking we'll probably do that.
I just won't be able to do it on Wednesday. Like I'll be out of town.
Okay. 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 I think last class we went through this right together. Solving equations 1. If you weren't here, that should be, if you go to the YouTube recordings, that should all be here. I believe yeah, I think that's it. That would have been from Thursday. No, I must not have Thursdays up. Let me see if I have that somewhere. Hi, Jared.
What's up?
How are you?
Pretty good.
Good.
Can I ask a question?
Yes. Let's log that.
Oh, it's Jared.
Yep. Put you on the clickers up there. Okay. We were just going to go over some more of those problems. Help you guys practice. And I'll record this and post it. I was looking, I thought I recorded our last class together. Did I? I'll post that after this school day. I'll have to look for it. But you can use those videos in the playlist to help you. Oh, I should present my screen. Okay, so let's maybe go through solving equations 2 and, if we can, some of the line questions, linear relations questions. I'm going to do, I've made them into like PDFs here, so you can print these out if you want. I'm just going to go to the My Open Math version. This is us. Okay. Can you guys read that okay? All right, so do you guys remember, let me pull this over here, actually. Do you guys
It's gonna be
remember?
on the first test.
Maybe not, no, not the ones with the linear, the linear equations. We'll start lower, I guess, and do some ones that will be more on the first test, I guess. And then we can go back. Yeah, so maybe question 14 we'll start with. All right, this one, you have to distribute values inside your parentheses. You want to isolate x all by itself on one side. So you'll have to combine like terms. So I'll just work through that one, I guess, with your help. Let me just figure out a way to copy it. I guess it's probably the best way if I just take a screenshot and then have like paint over here. I don't have to like memorize it. Okay, perfect. All right, so this one is 3 x plus 5 minus 4 equals 6 times x plus 7. And we want to solve for x. What should I start by doing?
Distributing properly.
Good, yeah, I want to make sure I get that 3 multiplying onto both terms there. And I'll do the same with 6. So what does that give me?
3x plus 15 minus 4 equals 6x plus 42.
Good. Excellent. Then I got some like terms here. They have no variable. 15 minus 4 is 11. And we have this. What's my next step?
Subtract 11.
Okay. So I got 3x on this side all by itself, and 6x plus 31. Now what should I do?
Okay. Subtract 6x.
Yes.
And then divide by -3.
Good. Is that okay with everybody? So x is 31 over -3. Let's see if it'll take that. Good. So those ones aren't too bad. 15 works.
If we just put it like that on the test, would we get it right? Or do you want us to make it a decimal?
No, that'd be right. Yeah.
Okay.
There was no canceling that, so that's fine. Like there's no way to reduce that one. This one's similar. You're going to distribute the 2, subtract, what was that, 112, and then divide by 8 to get x. So I'll leave that one, but that works the same way. Similar with this one, right? We'll do that one for practice too. On print screen. Whoops. Have to do this. That. Okay. 8. All right. So we'll do one more of these. Whoops. It's 89. All right, anybody else want to try this one? What's my first steps be? Distribute. What do I get when I distribute?
4x minus 40.
Good. That'll make 4x minus 49 equals 14x minus 89. What should I do now?
Add the 49.
Good, okay. I'm adding 49. Does that just make negative 40, I think? Oops, negative. Then what should I do? Good. Negative 10x equals negative 40.
And can that reduce?
What's that?
Like, can you divide like negative 10 by negative 7?
Yeah, we can divide the negative 10. And then zeros cancel. The 2 negatives cancel. So x is 4. Is that okay? Good. We'll put that in. Good. Now this is just more of the same here. Just combine the like terms. So add 3, get negative 5x. Subtract 15, so negative 5x equals negative 15. Divide by the negative 5, it should be 3. Let's try this one. This one's a little different. We have negative 4a plus 3 divided by negative 5 equals 6. How should I start this problem?
Multiply by negative 5.
Good. And then you should get negative 4a plus 3 equals negative 30. And now it's like the others here. We're just going to, I guess, subtract 3. And then, to finish it,
Divide by negative 4.
good. That makes it positive. 33 divided by 4 can't be reduced. So there we go. How about this one? Change colors for you. we have y divided by 5 plus y divided by 2 equals 7/9. If I want to add two fractions, what I have to, I need them to have a common denominator. So this one over here is missing a factor of 2, so I'm going to do 2 over 2. And this one on the right is missing a factor of 5, so I need 5 over 5. Are you guys okay with that?
What was that? Like, what do you do?
I want them to have a common denominator. So the factors of this thing down here is just 5, and this is just 2. So I need them to have what the other one has. So I need to give this a 2, and I need to give this a 5. Right? Now, if I put a 2 down here, I've changed what this is. I've changed it. And I don't want to change it. I want it to be equivalent to what it is. So I'm going to multiply, 1 is 2 divided by 2. It's 3 divided by 3. These are all equivalent to 1. And if you multiply anything by 1, you don't change it. It's just itself. So what I'm doing is I'm multiplying by 1 in a way that doesn't change it, the value of the fraction, but it changes the way it looks. So instead of having a reduced fraction, I'm going to double the top and double the bottom. That way, I haven't changed it, but I do now have 10 in the bottom. On the other side, I'm missing a 5, so I'm not going to change the number. I'm going to multiply by 1, but if I write it this way, then it will have a denominator of 10.
So both of them will be like, or one of them will be 2 over 10, and the other one will be 5 over 10?
2y over 10
Oh,
and 5y over 10. Yeah. So now that they have the common denominator, you can combine them more straightforwardly. You can add the tops now, which makes 7y. Does that make sense?
so you have to combine the two.
Yeah. To solve for y, we want to get y by itself on one side of the equation. So if you've got two terms with y in it, you've got to combine like terms. This one happens to be fractional, so we had to combine the fractions through finding a common denominator.
So if it were like x and y, would you still combine it? Or
No, you couldn't combine it then.
Okay.
Well, I mean, you could, like if you had like x over 5 plus y over 5, you could get x plus y over 5, but you couldn't really merge those into a single term. Because they're not like terms. All right, so now I've got 7/10 of y is equal to 7/9. So I am going to, you can think of dividing by 7/10 on both sides. And that cancels here. But when you divide by a fraction, it's the same as multiplying by its reciprocal. So those cancel. So it's just 1 down here now. You could think of it that way, or you could just say, okay, because I had 7/10 over here, I'm going to bring it to the other side as the reciprocal, so 10/7. So now y is equal to 7 over 9 times 10 over 7. The 7's cancel, and you get 10/9 for y. Is that okay? You want to see it again? So I have 7y over 10. That's what we had when we combined the terms. Equals 7 over 9. I want to get y by itself. So I'm going to multiply by the reciprocal of 7/10 on both sides. I have to do the same to both sides. That gets rid of everything that's multiplying y. So I get y by itself finally, which means I've solved it. I just got to clean up the right-hand side. You could say 70 over 63, but I see that they both have a factor of 7. You just multiply the top and multiply the bottom. But they both have a factor of 7, so those factors of 7 can cancel on the top and bottom, and you just get 10 over 9 left over. Is that all right? Which I believe is 1.1 repeating. I'm just going to put it in like that.
Just like put it.
Yeah. Yeah. Okay. Those are the solving equations ones. I believe that there were some 2 variable ones in the linear stuff, so I'm going to save the stuff that's about slope and like the graphs of lines and the line that goes through a point. That'll be on the next test. So these questions up to 14 are going to be on the next part of the test rather than the first part of the test. But 14 on down are going to be on this first part of the test. Let's see what's in here. So these are going to be second part of the test. These rate,
Part?
yeah, so like rate or like slope. We'll hold off on those. This is all probably second part. Yeah, most of this is second part. Okay. Yeah, I'd say that one's all second part. This one. That one could go on either. It is graphical. It shows lines, so I could save that for the second part. But when we're solving systems of equations, we're sort of sticking with linear equations at this point. So the idea that when you have a system of equations, like 2 lines, the solution to both of them, if you wanted to find a solution that solved both of them at the same time, it would be where they intersect. Those are the solutions. So the solution to this system would be my x is 2, and my y looks like it's -1. So I would just say over 2 and down 1, and that's the solution to the system. Does that make sense? Okay, so we have different possibilities for solving a system of equations when you have 2 variables and 2 equations. Your possibilities are you could have 1 solution, you could have no solutions, or you could have infinitely many solutions. And so remember that solutions are points that are on both lines. So the one solution is when I'll just draw lines, and the other line will be, that one has 1 solution. If they're parallel, there will be no solutions because the distance between them stays the same. They never intersect. Here, the distance is shrinking, they intersect, and it expands. Infinitely many solutions is when the lines completely coincide. They're the same line. They just might look different. So examples of one solution would be y is equal to x minus 1, or y is equal to minus x plus 2. You see that they have different slopes, so that means they trend differently, which means somewhere they're going to meet because they don't have the same slopes. The no solution, these lines would have the same slope, but they have different y-intercepts. So they travel in the same way, they're parallel, but if they don't touch at one place, they don't touch ever because they go the same way. Infinitely many solutions, let's say y is equal to x minus 1. The other one would be the same equation. It just might look a little bit different. So like if I doubled both sides, I might have like 2y is equal to 2x minus 2. And those two equations are basically the same relationship. So these are the three possibilities that you could have with solving a system of linear equations if you have two equations. One solution, no solutions, infinitely many solutions. Does that make sense? Good. This one had the one solution. This one wants you to solve the system by graphing. That'll be saved for the second part of the test. Same. This one, they just want you to say which of the points that they've labeled. So this looks like the point 0.04, this is the point 0.01, this is the point 1.0, this is the point -4.0. And this point looks like it's, this is the solution, B. I guess I just have to say B, don't I? I don't actually have to look at what the point value is. And yeah, so that the solution will be at -1.5, comma 2.5.
So.
Yeah.
How do we know where to put the point?
On that one, you're just saying which of those points is the solution. And that's where the lines cross.
Oh, gotcha. Okay.
The other ones are just intercepts.
Okay.
So you have y-intercepts, and you have x-intercepts. And those are not solutions unless both lines happen to intersect there. It's where the two lines intersect each other, not the axes. Okay.
So is that going to be on the first test?
No, that one would be on the second. Well, that one really could be on either. Like just the idea that when you're solving the system, that it's where lines cross. But that's both about linear equations, and it's about solving equations. So it's kind of could go either way.
So it was like the stuff to study on was on my map,
The what?
like stuff to study on.
Yeah, all this is on my open math.
Okay.
So, and I also made these as PDFs, and they're also in the classroom.
Okay.
So like, what am I doing? Where'd the classroom go? I think I moved the classroom, but if you go to the classroom, you can see PDF versions that just have all the questions listed. So now how do you solve a system? This one says use the substitution method. So we'll go through that. You could also use the elimination method, and you can also use Cramer's rule to solve systems or equations. We'll do all of them. We'll go over every way. Some ways are more convenient than others, depending on the problem that you have. This one was, let me switch to a more darker color. supposed to be an 8. Keep on messing it up. This one said substitution, so I can use substitution, I guess. I guess I'll rewrite that first equation as I'll just subtract 5x from both sides. So I'll have x equals 5y minus 5y minus 52. So now I know what x is in terms of y for one of the equations. Now I want to find the solution to both, the place where both equations, a point that's on both equations. So any value that satisfies this, that makes this true, would be a solution to this first equation. And so they have to follow this rule. Now I'm going to put this into the second equation and find the thing that not only makes this true, but that makes the other one simultaneously true. So I'm going to put what x is, this stuff, and I'm going to put it into for x. So I'll rewrite 4, and then plus y equals minus 18. And all this stuff goes inside of the parentheses. And this is the substitution method. We're substituting out x, and now we have one equation with one unknown y. And we can isolate y and therefore solve for y. You guys we were doing these before. You got to start by distributing now. So I'm going to get negative 20y. And then I'm going to distribute the 4 and multiply the negative 52. Well, a 5 is in the tens place here. I know 4 times 5 makes 20. I'm going to put a negative 20 in the tens place. In the units place, I'm going to do 4 times 2 and get 8. That should be negative 208. And I still have the plus y equals minus 18. I'm now going to combine like terms. So the negative 20y and the plus 1y makes negative 19y. And then I'm going to add negative 208. I'm going to add 208 to both sides. So if I add 8, that gets rid of the 8. And then it's basically 200 minus 10 then, so it should be 190. Finally, I'll just divide by the negative 19. That gets rid of it here. This will be, y is going to be negative 10, because 19 parts cancel and you're just left with a factor of 10 in the top, or minus 10. That's y. Now I can plug that back in for my expression for x that I had before. I could plug it into either one, it doesn't matter. I could plug it into either one of my original equations. I'm going to say now x is equal to minus 5 times what y is, that's negative 10, minus 52. And once I solve this, I'll have x as well. So this is going to make 50 minus 52. So that's going to come out to minus 2. So my answer should be, if I did all that adding and subtracting properly, minus 2 comma minus 10. X comes first. Are we okay with that? All right. So that is one method of solving a system of equations. This one's called substitution. You kind of isolate one of your variables, substitute what that variable equals into the other equation. Then you can solve for the other variable and plug into either one of the original equations and figure out what the other variable is. Okay. Here's a -2, -10. Good. All right, this one, let's see if I can. I'm going to do this one. It says substitution. I'm going to use elimination just to use the other method. Either one should work. That was -x plus y is equal to 1, and 4x, let me clean that up. 4x minus 3y equals -4. All right, now this method is elimination. I'm going to rewrite my first equation as, it doesn't matter. I can multiply every value in this first equation by 4 to eliminate the x's, or I could multiply everything by 3 and eliminate the y's. I guess I'll go with 3 because I like smaller numbers. Or I like, when I multiply and add, I like to work with smaller numbers. I'm going to go with multiplying every term, every term in the first equation by 3. So I'm going to have -3x plus 3y equals 3. This does not alter the expression if you do the same to both sides, or equation, I should say. But now I can eliminate the y's when I add the left-hand sides and the right-hand sides of these equations. If I add the left-hand side, the y's cancel, but 4x minus 3x is just x. Y's, there's no y's, they go away. And I get -1, so I've already got x is -1. Are you guys okay with that?
How did you get like the equation?
I just multiplied every term in the first equation. That's a legal move. It doesn't change it. I did that so that I could get I wanted the y's to match, so it'd be the same size. That way, when I add them, they get eliminated. So now, once I get that x is equal to -1, I could plug into either one of the originals. I'm going to plug into the first one because, like, there's not all the coefficients are 1 or -1 here, so I like that. It's nice and simple. I'm going to rewrite this as minus, and then x happens to be -1, and plus y is equal to 1. 2 negatives make a positive, so 1 plus y equals 1. So y's got to be 0. You add something to 1 and you still have 1. That means you didn't add anything. Or you could just subtract 1 from both sides, and you'll get that y is equal to 0. So as a point, I would say, as an ordered pair, I'd say -1, 0. So this point will be 1 unit to the left on the x-axis where they cross. Is that okay? Oops. There we go. So you have those two methods. Let's do, I'm going to do that same one again because I liked how this one had such small values. I mean, you can do it with bigger values, but this one's just nice and convenient. So I'm going to come back here. I'm just going to clear that. I'm going to write that again. -x plus y equals 1. 4x minus 3y is -4. So we've,
Are you gonna do that as substitution?
what's that?
Are you gonna do that as substitution or?
I'm going to do Kramer's rule for this one.
Oh,
So we've gone through now the two normal methods that you would use to solve your equations. But here is a third. So here I'm going to define the coefficient matrix. You can use any letter you want. I'm going to use D. And so my coefficient matrix will be, I just take these coefficients, -1 for x here, and 4 for x here. For the y's, I have 1 and -3. And that's my coefficient matrix. I'm going to make two more matrices. This one is the X matrix. So I write the same matrix as before, the coefficient matrix, but instead of the X column, I swap those two numbers out for these two numbers that are on the right side of the equal sign. So 1 and -4 will go here. Maybe I'll choose different colors. Yeah, maybe I'll do that. So 1 and -4 go in the X positions. And then the same Y values as before. That's the X matrix. The Y matrix is the same as before that we had from the coefficients, -1, 4. But for the Y values, I'm substituting in this other set. So the Y's get swapped out for 1 and -4. Do you guys follow that? All right, just a little note about, I'll do a different color, about the notations. So I've named this matrix D. When I say D with absolute value signs around it, that means determinant. Find the determinant. So that's, it looks like this. You just use straight brackets. And to find the determinant, you are going to, you're going to have these guys, and you're going to have these guys. If you recall, so I'm going to have -1 times -3. Then I'm going to subtract 1 times 4. I'm just going down the diagonals, and I find the difference. So this makes this makes +3, -4. That makes -1. The absolute value of the D matrix, or I should say the determinant of the D matrix, is -1. Is that okay? All right, I do want the determinant of the other matrices. I'll go back to purple. So that determinant of dx is 1 times -3 minus 1 times -4. So subtracting a negative makes addition. So -3 plus 4 is 1. That's the determinant of the X matrix. The determinant of the Y matrix will be 4. -1 times -4 makes 4. I'm going to subtract 1 times 4, which is 4. So that determinant is 0. Now, so this method has you make 3 matrices. One of them is used twice, and the other 2 are used, the X matrix is used to find the solution to the X variable, and the Y matrix is used to find the solution to the Y variable. So in Cramer's rule, X equals the determinant of the X matrix divided by the determinant of the coefficient matrix. So I just have to take the determinant here, 1, and divide it by the determinant here, -1. So X equals -1. That's my solution to X.
A lot of these problems.
Not a lot, but there'll be some.
So long.
They're shorter when you get to 3 variables and 4 variables. Like, I think it's an easier method when you get to harder problems. So that's kind of why we're going over it. The Y variable would be this determinant over the coefficient matrix determinant. So 0 over -1 is 0. So once again, we found that the solution is -1, 0. So it's just another method for solving it. Now, remember that there are 3 possible outcomes when you're trying to solve a system of equations. There could be one solution, that's like this, we got one solution. There could be no solutions, or there could be infinitely many solutions. This method, if there's a solution, you'll get numbers here for X and Y. If the coefficient of the if the determinant of the coefficient matrix is 0, well, you have to put that determinant in the denominator, and you can't divide by 0. So whenever this comes out to be 0, that means you either have no solutions or infinitely many solutions. So Cramer's rule can't really distinguish between those. So you're going to have to check them out to make sure either it's the no solutions or it's infinitely many solutions. So you'd have to use a different method. Is that okay? All right. That's most of it. Let me go over what it looks like when you have no solutions. So I said that if you had an equation, let's say y equals x minus 1, that's a line that looks like this. And then if I take a parallel line, y equals x plus 1, that'll look like that. They're never going to touch, so there's no solution to this system. So I'm going to write that as a sort of system of equations. So here we go. Let's say I give you this system of equations. And let's try to solve this using elimination. All I've got to do is add the left-hand sides and add the right-hand sides. So what do I get when I add the left-hand sides of these two equations? Or I should say, I should subtract. So I should subtract these. Minus x minus a negative x would make plus. So minus x plus x makes 0 x's. Y minus y makes 0 y's. So if I subtracted the left-hand sides, I would get 0 on the left. And if I take -1 minus 1, I get -2. This is false. 0 does not equal -2. So when I tried to solve this using elimination, I got a false statement, which means there is no value of x where if I plugged it in, I would get the same y value. These will never touch. There's no solution. Sometimes people write the symbol for the empty set. An empty set is a set with nothing in it. But there's no solution. That's what it looks like when there's no solution. You'll try to solve it and you'll get something ridiculous. Okay? Now, here's the case, I'll do a different color, when you have infinitely many solutions. So we'll say -x plus y equals -1 and -x plus y equals -1. Now, if I use the elimination method and I subtract the left-hand sides, I'm going to get 0. But when I do the right-hand sides, I'm also going to get 0. And 0 does equal 0. This is a true statement, which means that every value of x will give me the same y in both equations. So this has infinitely many solutions. So whenever you're trying to solve these, if you get something false, no solutions. You get something that's always true, every point represents a solution. So that's what it looks like when you get to those cases. Cramer's rule will not be able to distinguish between these two scenarios. You won't be able to use Cramer's rule. Let's take a look. Because we got to clean up dust, but that is it. That'll be everything on the first part of the test. Ready? Clean up. Yeah, you think it goes here. What's that?
Why are you saying?
Oh, it's 35. I was thinking like 10:35. Sorry.
It's
We got a few minutes.
11:55.
You're right.
Have you got 55?
I saw the 35 in my head. Thought it was time.
So this is elimination.
Yeah. Substitution, Cramer's rule. That was for systems of equations.
This is for the first test.
Yeah. The solid equation. So when you have one equation and one unknown, you just isolate that variable. When you have two equations with two unknowns, one of these three methods will work.
Then it's gonna be like finding.
Yeah, then I have ones that are just like, what's the solution?
Okay.
You have the lines crossing. What's the determinant of this matrix?
And those are gonna be 3 by 3.
There'll be some 2 by 2s, there'll be some 3 by 3s, but you're not gonna have to do the 3 by 3 method for Cramer's rule.
And then this would be, putting words into an expression.
Yeah, so the stuff that we went over on solving equations 1 last class, that was in that video. Like, what are the symbols for multiplication? What's a coefficient? That vocabulary.
Okay. And then it's solving equations 2, 14 down, right?
Yeah. So solving equations 1, I think most of that. 14 down, solving equations 2, and then these systems of equations, the linear relationships. I'm not really going to be testing on graphing lines or where they intersect on this part.
And there's gonna be no slope and slope or point
Yeah,
slope.
not on this one.
Okay.
It's not so much about thinking of them as lines. It's just finding the solutions to equations.
Okay.
They are linear equations, but we'll hold off on the linear aspect of them right away.
Can I go to the bathroom?
Yes. All right.
Alex, there's something extra that you just wrote down.
I'm going to end the call, Jared, so that Google can process the video and send it to me so I can upload it to YouTube. Just a little later in the day, these will be available on YouTube. So I'll just make sure you don't forget that you have these available to you. All right. Have a good day, Jared.